So one of the students asked me about the pressure calculation for the retaining wall. It is actually a mistake that it is not 1320, it is actually 0 at the top, and here we have 1320, right? That pressure in here is 1320, and pressure at the top is 0. But ETAB is taking it as Z11 at the top and Z0 at the base. That's why we have written this calculation on the basis of the ETAB. Another student asked about the calculation for the brick load, that how did this 860 pound we have calculated, right? So this was question was asked by Hassan Ali. So this is the total length of the walls we have calculated. Like this, we have some all of these lengths, and this is the height of the story. This is in feet, and this is the 9 inches. So we have converted these 9 inches into 12 feet. So we have divided this by 12. So when you do this in calculator, or you can do it in Excel sheet. So let me do it quickly for you. So it is 104 into 11, and into, if you divide 9 by 12, it's come out to be 0.75. So it is 859 pounds. So we have taken it as 860 pounds. So this is how you calculate the, oh no, we haven't multiplied the weight. This is right. This is 120. Then we'll get the total load. So now we have 102 keep total load, and this is or in pounds. So we have to convert this into PSF. So we have to divide this by 20 into 27. This was a very good point, that we have forgot to multiply with the density of the brick. जी मतियुल्लाह, कोई क्वेश्चन है आपका? हेलो
सर, the Matullah mic not connected.
हाँ जी. So we are talking about the calculation for this brick wall, that we do not want to add these loads on the beams because they are nesting on the beams. So this was the total length. This was 104 feet. So we have to multiply this 104. This is the length, this is the height, and this is the thickness. So we have to multiply this with 120 pound. This is 120 PCF, which is the pound per cubic feet. So after multiplying this, you will get the total weight. For example, we have done it here. So this is 104, and this is 11, and then 0.7, this is thickness, and 120 is the density. So we are getting this much load. So now you have to divide this load. So I'm getting very high load, don't know why. This is 20 into 27 feet. This come out to be 190 pound per square foot, right? So then you have to apply this load on the slab that we have this model. Let us show the floors. So this was the panel on which we have multiplied, we have this extra load. So you can see this is 20 and this is 50, right? And same is for the other. So you have to multiply, apply these loads on the floors. So I have already applied these loads on the another model. So because we will be running this model, so it will take a lot of time. So this is the another model in which I have applied these loads. So because to save the time, I have saved as this previous model, and then I have run the analysis to go to the analysis results like the drifts and irregularities, right? So these towards the mistakes in the slides. First one is this load. This is not. This is somehow to be 102 kept, right? You can verify these loads and you can inform me like that these two students did. So we can edit and verify these loads, right? So you have to divide this and you will get the total load of 190, right? So this is 190 and you have to apply this 190 PSF load only on these panels for which you are designing, right? So I have already applied these loads on these panels to in order to save the time for our next session, right? So in our next session, so I hope these two things are clear, right? So we should move on. Is it clear?
Yes, sir. Clear.
So today is our session 7, in which we will have 4 parts. First one is the drift check as per UBC 97, and then the torsion ability check, and what will happen if there is a drift issue, what is the solution, and what will happen to the structure when there is a torsion ability, and what is the code limits and how to solve this issue. And then we will go towards the design of columns as per ACI, and then at the last we will have design of beams as per ACI. Matula, kindly please turn off your camera. Right, so let us start. I have already run the analysis in this model. This is the same model, but I have said
हेलो सर, आपका माइक बंद है।
all right. So this is our first slide for the drift check as per the UBC 97. And this section says that in UBC in Building Code of Pakistan section 5.30.10, that for the story displacement you have to use the maximum elastic response delta M, right? So delta M is actually the response coming from the inelastic analysis. If you perform a dynamic analysis like time history analysis, so you do not have to calculate this maximum inelastic response delta M. But if you are performing elastic design or linear elastic static analysis, which we are doing for the design, so you must have to calculate this delta M, right? So this is the code statement which is defines the limitation for the drift, but I have simplified it for you. That is the drift limitation delta M is calculated as delta M is equal to 0.7 R into delta S. And delta S is the elastic displacement that coming from your elastic response analysis, right? That is, for example, you are getting the deformation in ETABS. So that deformation is actually delta S. So you have to multiply that delta S into R and then 0.7 to get total delta M, right? So there are two conditions for the buildings having fundamental period equal or greater than 0.7. So the limitation is 2% drift, 0.02. The second option is if the building have a fundamental time period less than 0.7 seconds, So 2.5% drift is the limitation, right? So you have to first of all check the fundamental time period for the building. So you can select the limitation for whether it is 2% or 2.5%. And then you have to multiply the delta S coming from ETAB with R and 0.7 to get total delta M, right? So let us go to ETAB and let us see our fundamental time period. You can see it by going to display, deform shape, and click on the mode. So the first mode is actually the fundamental mode of the building. It will be the greatest one, right? So after clicking on the apply, you can see on the top that in mode 1, the time period is 2.178 seconds, right? As long as you're going up, the time period will decrease, right? So now you can see in mode 4, the time period is 0.572, right? So your fundamental time period is, remember that fundamental time period is the largest time period of the building, which is normally mode 1. So in mode 1, the fundamental time period is 2.178. So our limitation for a building is the fundamental time period is greater than 0.7. So the limitation of a building is 2%, right? Some of the students text me that there is no sound.
Sir, he did not connect his mic. Sir, Matiullah has problem of mic. He cannot connect his mic. He doesn't know how to connect his mic.
Right, Matullah, the session is on, right? So please check your mic and speaker. So we are talking about the building limitation. So for our building, the limitation is 2%, right? So how do we calculate this drift? So let us go to ETAB. So this is the same model I have run analysis already. So you have to go to the display and click on the story response plots, right? So this window will appear. From the display type, you have to select the maximum story displacement. And then for the design, for the case or combo, you have to select the earthquake, that is earthquake in X, right? And you have to select the story ranges. So you want to basement into top, right? So this is the response of your structure, maximum story displacement. You can see the coordinates right here. So this is actually the response of your structure when it is subjected to earthquake forces. This is the lateral displacement of your structure. So this is actually mode 1, right? If you know about the single degree of freedom system, that in the dynamic analysis, this is the shape of the mode 1, right? So let us use the Excel sheet to calculate the our drift in our structure. So you have to go to this show table and click on the formatted. So this table will appear. So you have to extract some of the information. We have to insert this information in our Excel sheet. So you can see on the top, for the earthquake in X direction, on the top, the maximum displacement is 2.3 inches, right? So you have to select these elevations. So take a copy of this by Control C and go to this drift calculation sheet, and you have to insert the value in here, right? So this is the value, and you have to insert the R value you have used. So we have used 8.5, so we will be using this 8.5 value, right? So now the next part is you have to insert delta S for X direction and delta S for Y direction. So this is delta X, delta S for X direction. So Control C. I have prepared this Excel sheet, so I will share it with you, right? So this is the delta S, and next one is the delta Y. So we have to select earthquake Y, and again go to this formatted table, and now this time you have to select this. delta 1. So now you can see in this Excel sheet that I have inserted the story levels, story elevations. This is actually story elevation. These are not height. Story elevations in feet, right? And this is the response modification factor. This is the delta S value coming from ETAB. This is delta S value coming from ETAB in the Y direction. This is X direction. And this is delta M. It is calculating it for you. If you see the formula, I have multiplied this with 0.7 and into R and this delta S, right? So this is the delta M. This is the inelastic deformation of the building. And this is delta M in Y direction. So now this is the drift in X direction. And this is the drift in Y direction. So you can see that our building is more stiff in the Y direction. This is our Y direction and this is our X direction. So in Y direction, it is more stiff. So that's why there is no issue of drift in the Y direction. But on the X direction, the system is a bit less redundant, or you can see have less stiffness as compared to the Y direction. So that's why there is an issue of drift in our X direction, right? So you can see the drift limit. This is 2.162. So for our building, the drift limit is 2%, and the drift in our model in X direction is greater than 2%. So there is an issue in the X direction and there is no issue of drift in the Y direction. So next is, what is the solution for it? So this is the torsion. So if the drift is out of range, then provide shear walls to control it, right? So this is the solution if you have drift value greater than the code recommended. So the code limit is 2%, and we have in the X direction is 2.02 and 2.29. So we have to provide shear walls in our structure system, right? So let us undo this. So you can see that if I provide the shear walls in the X direction, so it will give enough stiffness to the structure not to deflect or drift in that direction. So whenever you have drift in a X or Y direction, you have to provide the shear wall parallel to that direction. So this is our X direction. So the X direction, as you can see, is this one. This is the X direction. So we have to provide the shear wall parallel to in the direction of that axis. So we have to provide the shear walls in this X direction in order to control the drift in the X direction. So first of all, you have to go to the ETAB and you will have to see this situation that where you can provide the shear walls. So first of all, the common practice is that you have to go through the architecture plans and see whether you are providing the shear walls is not disturbing the corridors or the not blocking the window or the door of the architecture. So then after proposing these walls in the different locations, you have to send this file to the architect and tell him that we have proposed location of the shear walls. So please check it. If there is not an issue for you, so we will carry on with the analysis, right? So we have to provide the shear walls in the X direction. So this is our X direction. So if you provide shear wall in here, so there is no issue in the parking, right? So you can provide the shear wall in this grid. So you have to check it for the top stories. So this grid is actually the grid 7. So if you provide a shear wall in here, so it's not disturbing any windows or office, so you can provide it in here as well. So then you have to go towards the shops. So these are the shops. So it's not disturbing any shop. It is not disturbing any office. Like in here, different locations you have to check for your architecture. And then you have to arrange a meeting with the architect. So in our case, if you provide a shear wall in here, so there is no disturbance in your architecture. If this corner, And if you provide a shear wall, one shear wall in here in this grid, and if you provide a shear wall in here, and if you provide a shear wall in here, so there is no, let us see that if you provide a shear wall in this grid, so there is also no issue. But if you go up, there is a corridor. You have to see it very carefully. If you provide a shear wall in this grid, so it's blocking your passage, right? So you have to take great care while proposing the shear wall locations. So we have to provide shear walls in different locations. We can provide in here, we can provide in some middle portion in here, we can provide in this direction, in here, many options it can be. So let us go to the ETAB, and we have to select the all stories, and let us define section for the shear wall. So add new property, and let us click shear wall. Give the strength value equal to 6000 psi, and the thickness, the minimum thickness you have to keep is the width equal to the width of the beam. So the width of the beam we have 12 inches, so we will keep it 12 inches. So we'll click on OK. Right. So let us draw these shear walls. So we have to draw one of the shear wall in this direction, in this corner. Let us draw another one in this corner. Try to give the shear wall at the opposite direction of the corner, so it will give you effective results. And let us give one in here. So you have to check it in our model first, and then you have to give these information to the architect that we have provided this shear wall, please check. Right. So now I think these 4 are enough. If there is a need, so we can provide another one in this location. Right. So let us run the analysis. But before going to the analysis, let us go to the over here on top. If we do not want any shear wall in here, let us delete these. So now we are ready to run the analysis. So while it's running the analysis, if there is any questions you can ask.
सर ये शेरवाल बहुत ज्यादा आपने नहीं लगाया पीठ सर्विसेज में, तो नॉर्मली 1 या 2 शेरवाल मतलब कंस्ट्रक्ट होते, इतने ज्यादा तो नहीं होते।
क्यों नहीं होते? अब हमने अभी रिसेंटली कोई प्रोजेक्ट्स किए, उसमें हमने 8 शेयर वॉल्स दिए। ये आप देखेंगे, बिल्डिंग्स को देखेंगे ना, बिल्डिंग अगर आपके पास काफी बड़ा है तो उसमें आप 10 भी दे सकते हैं, 12 भी दे सकते हैं। एज लॉन्ग एज आर्किटेक्ट को कोई इशू नहीं है तो आप जितने ज्यादा शेयर वॉल देना दे सकते हैं, आप दे सकते हैं। आपके पास अगर बिल्डिंग काफी लंबी है तो 1-2 शेयर वॉल से तो वो कंट्रोल तो नहीं होगी।
अच्छा ठीक है सर।
ठीक है, जब आप आर्किटेक्ट से, अगर आर्किटेक्ट को कोई इशू नहीं है तो आप जितने शेयर वॉल देना चाहे आप दे सकते हैं।
हेलो सर।
जी जी
सर मैंने सेशन अभी ज्वाइन किया है, तो आप काइंडली ये बताएंगे ये कैसे डिसाइड किए कि कहाँ पे मतलब पोजीशन, शेयर वाल की पोजीशन कैसे हम डिसाइड करते हैं?
ये तो नॉर्मली मैंने बता दिया, आप वीडियो पे दे सकते हैं रिकॉर्डिंग।
जी जी सर, जी जी जी।
नॉर्मली आप जो हमारे एक्स डायरेक्शन में उसमें ड्रिफ्ट ज्यादा आ रही थी तो हमने एक्स डायरेक्शन में शेयर वॉल देना चाहा, तो आप वो
जी सर।
लोकेशन सेलेक्ट करेंगे जहाँ पे आपके ड्रिफ्ट भी कंट्रोल हो जाए और आर्किटेक्ट को कोई इशू भी ना हो।
सर प्रीवियस जो रिजल्ट ने आपने रिजल्ट्स जो एक्सट्रैक्ट किए उनमें कहीं ये शो हो रहा है कि इस जगह पे आप माने जो शेयर वाले वहाँ इंसर्ट कर सकते हैं, ऐसा डेटा में है सर?
नहीं नहीं, ऐसा कोई आपके पास नहीं है, लेकिन आप खुद भी कंफर्म कर सकते हैं कि मैक्सिमम डिस्प्लेसमेंट कहाँ पे आ रही है। आपको वहाँ पे स्टोरी पे
ठीक
शो हो रहा है कि सपोज फॉर एग्जांपल ये मैक्सिमम डिस्प्लेसमेंट आपके पास ये 2.3, तो नॉर्मली ड्रिफ्ट आपके पास मैक्सिमम टॉप पे होती है, लेकिन किस कॉर्नर
सर।
पे हो रही है वो आप ETAB में वेरीफाई कर सकते हैं प्लेन व्यू में जाके।
ठीक है सर।
Hello, sir. Hello, sir.
हेलो,
Yes, sir. Hello.
हाउ आर यू?
Alhamdulillah, sir. I am fine. Sir, I have a question.
यस प्लीज आस्क।
Sir, our drift story is up to 7 stores. 7 fish. Our drift story, our drift system.
Sorry dear, I
sir,
cannot
can-
hear your voice very clearly.
Okay, anyway, I will. Hello, sir.
Hello? Gigi, please ask the question. So let us ask the question at the end of the session.
Hello?
Let us go towards the
Hello, sir.
analysis that we have run our analysis, and let us go again to the display, response story plots, and then again extract the maximum story displacement for the earthquake X, right? So let us select our story limit to the top, and then let us go again to the formatted one and select this. If you remember, for the displacement or the top for the X direction was 2 point something, so now it is 1.8. Let us check if it is worked or not. So copy this and place it in the X direction. So now again there is an issue in the lower stories that its drift is not controlled by these 4 walls, so you have to give another wall or maybe 2 in order to control this drift. So it is in the 4th and 5th story, right? So again you have to go to the ETAB, right? So let us unlock this again and go to the plane, right? So now you have to select another location in order to control your drift, but before doing unlocking the model, you have to check where in which location this drift is maximum. But it also again depends upon the location of the shear wall. If there is a restriction from the architect, so you have to choose the location on the choice of the architect, right? So let us choose another location and let us draw shear wall in here. Let's suppose this is the corridor, so we do not have any issue